In part 2 of our discussion on circles, we will take an equation that has been expanded out and put it back in standard form. First, let's talk about completing the square back when we studied quadratics. Here's a typical example. So here, what we did is we completed the square. What I taught you was we grouped the x's together. We took half of -12, squared it, and got 36. And then we subtracted 36 to keep the equation balanced. So we added 36 and subtracted 36 on the same side of the equation. And then, of course, we solved the rest of the problem. Okay. When it comes to conic sections, when we put them back in standard form, same idea, sort of, just a little bit different than what I taught you before. What I want you to do is you keep all of the variables on one side and then put all the constants on the other side of the equation. Now complete the square. We take half of -12, square it, and what we're going to do is we're going to add 36. But instead of adding 36 and subtracting 36 on the same side, we will add 36 to both sides. Hopefully numerically that makes sense, because when I continue solving the rest of the problem, it looks exactly like the method I taught you earlier this year. So, whereas this was more efficient when we were studying quadratics, here what we want is we want the variables on one side, complete the square, and add that constant on both sides. So keep that in mind as we put these expanded circles back in standard form. Okay, so just like before, we want to group the variables together. So we're going to group the x's together. So I have x squared minus 6x, and then we'll complete the square in a moment, so I'll leave a blank. Plus, we'll group the y's together. Okay, and then I'll leave the 6 on the right side. Okay, and also leave some room there because we're going to be adding a number to both sides. So to complete the square with the x's, I take half of -6 and square it, and we're going to add 9. And then I'm going to add 9 to the right side. Okay, let's repeat with the y's. To complete the square, we take half of -2 and square it. We get 1, and I'm going to add 1 to the right side to keep the equation balanced. I don't want to change the value. The x's become x minus 3 quantity squared plus, and then y minus 1 quantity squared equals 16. So therefore, our center is 3, 1, and the radius is 4 units. Okay. Second example. Let's repeat. Group the x's together. We will complete the square in a moment, so I'll leave a blank spot for the value that we will find later. We'll group the y's together. Okay, we'll leave a spot there to complete the square in a moment. And we'll leave the constant on the other side. And I've got 2 more constants that I have to fill in. So I will write blank and blank. Okay, for the x's, we take half of 4 and square it, so we get 4. I'm going to write 4 on the right side of the equation. For the y's, take half of -4 and square it, plus 4, and then plus 4 on the right side. Okay, so now we get x plus 2 quantity squared plus y minus 2 quantity squared equals 9. So therefore the center is -2, 2, and the radius is 3 units. Okay, pause the video and try letters C and D on your own, and then unpause it to check your answers. Okay, so let's see how you did. On letter C, I grouped the x's, I grouped the y's. For the x's, I got plus 16. I added 16 to both sides. For the y's, 25, add that to both sides. Clean up the equation. The center is 4, -5, and the radius is 7 units. Last example, letter D. Group the x's together, group the y's together. For the x's, to complete the square, we add 9. So we add 9 on both sides. For the y's, we add 36 on both sides. Clean it up. The center is -3, 6, and the radius is 8.